Hello everyone, today we'll talk about the solution to the problem longest square streak in an array. To solve this problem we'll make two observations. One observation is pretty weird, or it's pretty weird that it's necessary to make it, because here we have an array. We're interested in subsequences of that array, so not necessarily contiguous, and the condition on that subsequence that we're interested in applies to the sorted subsequence. So what we can notice is that a sorted subsequence of an array is the same thing as a subsequence of the sorted array. Right? So instead of thinking about sorting the subsequence that we select, we can just consider the original array sorted, and then the subsequence is just the subsequence of the sorted array. And in particular, that also means that we can think of our set of numbers either as completely unordered or as sorted. In our case, we'll sort it, so let's think about it in the order defined by the sort. And the second observation, more closely related to solving this problem, is that we're interested in this particular kind of streak within our array, and as opposed, for example, to something like an arithmetic progression or a geometric progression, a progression that has some parameter. So for instance, when it comes to arithmetic progression, we can have an arithmetic progression where subsequent elements differ by 1, or they differ by 10, or they differ by -2. So there is this added parameter, same for geometric progression, like multiplying previous element by 2. But in this case, there is no such parameter. For every element, there is a single defined previous element and a single defined next element, because those elements are related by one being the square of the previous. So that means, and whenever you have a situation like this, it means that the solution becomes simpler, because you can simply look up if this particular element exists, or where it exists, or something like that. And in our case, this leads us to an easy solution, because after sorting the array, we can just look if the previous, or if we're interested in looking backwards, because of course you can also look backwards, if the next element in the sequence has already been seen within our array. So this leads us to a solution that, as I mentioned, first of all we sort the array. We'll be sorting it in decreasing order, because it's easier to multiply numbers together than to take square roots, and we don't care about which is which when solving this problem. And we'll be maintaining the length for any given value of the longest streak that we've already seen ending at that value. So this is kind of a dynamic programming approach. And now for every number, what do we want to do? Well, we know that this number can be a sequence of length 1. So that's fine. However, if, and again, we're looking here back at the array sorted in the reverse direction, so the previous number in the sequence should be the square of our current number, so v times v. If that square was already seen as an end of a streak before, then we can extend that streak by 1. So we take the previous value of the streak and add 1 to it. Our seen dictionary is a default dict, which means that if square was not seen, then we have here the value of 0 immediately. So this is for ease of writing. And at this point we know that the longest streak that ends at v has that length on our prefix of the sorted array. And of course at the end, we're interested in the longest streak ending at any number, so we just take all the values in our dictionary and take the maximum of them. And of course we can just return it. The question here tells us to return -1 if there is no square streak, so subsequence of length at least 2. So we just have to if it out. If answer is less than 2, that means that the answer is equal to -1. And that's it. So those are two observations. One observation is pretty weird, which is essentially coming from the weird wording in terms of the question, but it's like subsequence, and then we sort that subsequence, so that essentially means that the array can be sorted, or that order doesn't matter. And the other, which is more to the point, to the mathematics of the case, that there is exactly one previous, one next element, so we can just check for that exact element.